Good morning, students. Today we will discuss advanced chapter 3, and chapter name is arithmetic of integers. So in these chapters, the first question is that mathematical inductions. In this chapter, most important topic is mathematical induction. So first question is this: what is mathematical inductions and where it will be used? Okay, so now you can see that mathematical induction is a technique for proving theorem of positive integers. Okay, for positive integers we can prove the theorem. Okay, so mathematical induction is a technique for proving theorem of positive integers. We cannot proving theorems of negative integers. Next, now we will discuss on principle of mathematical inductions. Now see, if a statement is taken, let the statement be P of n. Then if we satisfy for P of 1, that means for n value of 1, the statement will be true. After that, the value n is equal to k plus 1 will be true when n value of k will be true. Okay, then we can say the statement is true for all values of m. That means in the statement, if we put at first the value of n is equal to 1 and it satisfy both the sides and the statement, then after that, if we let that for value of p of k the statement is true, then at the last we can show that for the value of n is equal to k plus 1 the statement will be true. So let's see one questions. Now exercise 3.1. So the first question is that prove by mathematical induction that 1 plus 3 plus 5 plus dot 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 plus twice n minus 1 is equal to n square comma n belongs to n. This is the first questions of exercise 3.1, and let's see how do we have to prove this theorem by using principles of mathematical inductions. In the questions, okay, in the question, this one complete is called statements. So initially I have told that at first we have to take P of n is a statement. So in this case, statement is that one. This complete is called statement. So this one we will take at first what? P of n. So let it P of n. Solution. Let P of n is equal to 1 plus 3 plus 5 plus dot 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 plus twice n minus 1 is equal to n square. Okay, now nth term of the left hand side statement. Okay, this is from here to there is called left hand side of the statements. So n term will be what? This one. N term will be twice n minus 1, twice n minus 1. So therefore left hand side is equal to twice n minus 1. Okay, so for n is equal to 1, left hand side is equal to 2 into 1 minus 1. 2 into 1 2 minus 1 is equal to 1. Therefore right hand side is equal to, what is the right hand side? This is left hand side and this one is right hand side, and the right hand side value is n square. So you can take here right hand side is equal to n square. Again we have taken here n is equal to 1, so put here n is equal to 1. 1 square n is equal to 1. Then we can say therefore left hand side is equal to right hand sides. Okay, left hand side we got 1 and right hand side we got 1. So left hand side is equal to right hand sides. So therefore we can say the statement is true for n is equal to 1. Sorry, for n is equal to not k, for n is equal to 1, because at first we have put n is equal to 1. So the statement is true for n is equal to 1. That means this was the statement, complete statements. If we put 1 both sides, then the complete statement will be true for n is equal to 1. Okay, so as we have shown at first, that at first whenever we have taken a statement as p of n, then you have to satisfy number one condition, that p of 1 is true. P of 1 is true. That means whenever you put n is equal to 1, whenever you put n is equal to 1, then the statement should be what? True. So first condition here already satisfies, the statement is true for n is equal to 1. So first condition is satisfied. Now check for the second conditions. Okay, so what is the second condition? The second condition is that p of k plus 1 is true. That means whenever in place of n we will put k plus 1, this will be true when we take p of k is 1. That means whenever we will take in place of n k, if it will be true, then whenever we will take n is equal to k plus 1, and in that case the statement will be also true. Now check for the statement 2. Now let the statement is true for n is equal to k. Here we have told p of k plus 1 will be true when p of k is true. Okay, whenever we will take p of k is true, then p of k plus 1 is true. So the statement is true for n is equal to k. Okay, so we have considered that the statement is true for n is equal to k. Now we have to check that for n is equal to k plus 1, the statement is true or not. The statement is 1 plus 3 plus 5 plus dot 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 plus twice n minus 1 is equal to n square. Therefore 1 plus 3 plus 5 plus dot 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 plus 2k minus 1 is equal to k square. Therefore n is equal to how much? K. So we have taken that n is equal to k, the statement is true. So in place of n we have put k, and here also k, and this one left hand side is equal to right hand side, because we have already taken that let the statement is true. So this one already true we have taken, that means we have considered. Now we have to check that n is equal to k plus 1, the statement is true or not. Okay, now let's check. So now left hand side of the statement is p of n. P of n is a statement, and statement is 1 plus 3 plus 5 plus dot 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 plus twice n minus 1. So as we have take that, now we will check for n is equal to k. N is equal to k already taken. Now we will check for n is equal to k plus 1. So here I therefore for n is equal to k plus 1, therefore p is equal to k plus 1. See, n is equal to, we have taken k plus 1, so in place of n now it will be k plus 1. Okay, p same, in place of n we have put it k plus 1, because we have taken for n is equal to k plus 1. So put now 1 plus 3 plus 5 plus dot 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 plus, in place of n now put k plus 1, k plus 1 minus 1. Okay, this one n now, so in place of n we have put k plus 1. Okay, this will be bracket minus minus 1 1, same thing is there. Next 1 plus 3 plus 5 plus dot 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 plus twice k plus 2 minus 1. Next 1 plus 3 plus 5 plus dot 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 plus 2k plus 1. Okay, so students, now you can see twice k, 2 minus 1, that means 2 minus 1, 1. Now you can see 1, 3, 5, these are all odd numbers, and this one also be odd numbers. Okay, so before 5 odd number is 3, so before 2k plus 1 what will be the odd numbers? Okay, we know before 2k plus 1 2k will come, and after 2k it will be 2k plus 1, and before 2k it will be twice k minus 1, twice k minus 1. So this is odd number and this is even number, and this will be, we will ignore, we will take k plus 1, twice k minus 1 as before the term of twice k plus 1. Now you can see here what was there, 1 plus 3 plus 5, né? Okay, so therefore p of k plus 1 is equal to 1 plus 3 plus 5 plus dot 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 plus here plus twice k plus 1 is there. You can see twice k plus 1 is there, twice k plus 1 is there. So before this term, the term will be twice k minus 1. Okay, it will be what? Twice k minus 1, because before this term 2k, but 2k is even number, so we have to consider odd number because here all numbers are odd. So the before this term the odd number is twice k minus 1. Okay, students, now see very carefully. Now see from here, from 1 to 2 into k plus 1, you can see we got this value here, that 1 plus 3 plus 5 plus dot 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 plus 2k minus 1, 2k minus 1 is equal to k square. Okay, we have taken here, so here give equation number 1. Now see same thing, 1 plus 3 plus 5, 1 plus 3 plus 5 plus dot 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 plus dot dot plus 2k minus 1, 2k minus 1 is equal to k square. So in the complete this statement, that means starting from here to there, we can put value is equal to k square plus from here to there is equal to k square. See from 1. Okay, so k square, then left is was twice k plus 1, and this one we have to write from 1. Okay, so what is this? K square plus 1 we have taken. Now take, therefore right hand side is equal to, so what was the right hand side of the statement? So right hand side of the statement is that, if you see the questions very carefully, that right hand side of the statement is n square. Okay, so now we will take right hand side is equal to how much? N square. N value what we have taken? K plus 1. So put k plus 1 in place of n is equal to e square, then it will flow a plus b whole square formula. So a square plus 2a into b plus b square. So k square plus 2 into 1 2, next 2k plus 1 square means 1. That means this one is equal to this one. So this was the left hand side and that was the right hand side. So therefore write left hand side is equal to right hand sides. Okay, so therefore the statement is true for n is equal to k plus 1. Okay, as it is satisfy the number 2 conditions. What was the number 2 conditions? That if you take p of k is true, then p of k plus 1 must be true. So initially you can see here we have taken that statement is true for n is equal to k plus 1, and at the last we have got that the statement is true for n is equal to k plus 1. So condition number second is also satisfies. So at the last we can say that by the method of mathematical induction, the statement is true for all value of n and n belongs to n. This one n means Nusselt number, and Nusselt number is equal to, we know, 1 2 3 dot dot dot. Okay, this one is, so understand. When if I use solving this question answer, this part don't write, this one part don't write. I just write here what is Nusselt number. Till here you have to write, and this is the solutions. Okay, thank you.